Hello, this is Srinith. Our project is analysis of mangroves in Gujarat using Datacube. The domain is remote sensing, and the main objective of our project is to develop a data cube using satellite images to gain a better understanding of the mangroves, which includes tracking changes in their mangrove density, identifying areas where the degradation is occurring, and assessing the impact of human activities on this forest. This data cube provides valuable information for the conservation of mangroves. The technologies involved are Open Data Cube, QGIS, Flask, and deep learning algorithms. Coming to remote sensing, it's the process of gathering information about the Earth's surface from a distance using sensors mounted on satellites or aircraft. Remote sensing uses electromagnetic radiations to detect and measure the characteristics of object on the ground. The data collected through the remote sensing can be used for a wide range of applications, such as mapping the land use, monitoring natural disasters, tracking climate changes, and many others. Types of remote sensing are active and passive. Active remote sensing involves sending out energy in the form of radar or laser pulses and measuring the reflection of that energy by objects on the ground. Passive remote sensing, on the other hand, relies on detecting natural energy emitted or reflected by the objects on the ground, such as sunlight or thermal radiation. Active remote sensing is used for detecting changes in elevation. Passive remote sensing is used for identifying different types of vegetation. In our project, we'll be using passive remote sensing. So this is the image. So in passive sensors, the sun is the source. In active sensors, the sensor will be the providing light. Coming to the satellites, Sentinel and Landsat are two of the most widely used remote sensing satellites. Sentinel is a series of satellites launched by the ESA, European Space Agency, and Landsat is a series of satellites launched by NASA. Both these satellites capture different kinds of data in multiple spectral bands, and there are some differences in them. The major difference is the spatial resolution of the data captured. Sentinel has a higher spatial resolution than the Landsat. That means Sentinel can capture a detailed information in smaller areas. However, Landsat is a varied, extensive archives which is used for long-term analysis and monitoring. Coming to bands, there are 13 bands in Sentinel and 11 bands in Landsat. Now, these are the list of bands. Generally, we'll be using blue, green, red, near infrared, and small shortwave infrared in Sentinel 2. And on Landsat, we'll be using blue, green, red, NIR, SWIR. And in Landsat, the first 9 bands are OLI, and the 10th and 11th band are TIRS, that means thermal infrared. Now coming to the band combinations, combining of red, blue, green will be giving natural color. That means this color we will be seeing with our naked eye. Now coming to color infrared, this is the combination of NI, red and green. This color infrared band combination is meant to emphasize healthy and unhealthy vegetation. The white areas are the urban areas. The red will show the denser vegetation. Coming to agriculture, this is a combination of NIR, SWIR and blue. Agriculture band combines of these three, and it is used to monitor the health of these crops because of this how it uses the shortwave and near infrared. Both these bands are good at highlighting dense vegetation that will be appearing as dark green. Now coming to QGIS, QGIS is a powerful and versatile open source geographical information system that is used to view, analyze, and edit spatial data. However, QGIS is not useful for handling the large amount of satellite data, but by using QGIS, we can be able to perform basic analysis on satellite images, such as calculating areas, creating contour lines, and measuring distances. This is used for the very short-term analysis. And coming to data sets, data set is a collection of related data that is organized and presented in a structured format. In our context to the project, dataset typically refers to a collection of satellite imagery or other geospatial data that has been collected over a specific area and specific period of time. Each dataset consists of a metadata that describes about the data, such as the sensors used, the date and time of the observation, the spatial resolution, the spectral bands available. This is the most important part of the metadata, and this metadata is used to organize and search for the data within the dataset. Coming to Datacube, the most keyword in our project. Datacube is a multidimensional and time series dataset generated from satellite imagery, which can be used to monitor changes in the land use, land cover, vegetation, and other environmental factors. Essentially, this is the three-dimensional data structure that represents data along three axes: latitude, longitude, and time. The most important data cube operations are roll up, drill down, dicing, slicing, and pivot. Pivot means the turning the data cube into some angle and going through the attributes. Slicing is slicing through the each data set, and similarly we'll be checking about other operations further. Now coming to Open Data Cube. Open Data Cube is an open source software that that is designed to index large amount of Earth observation data, which is stored in file system or a cloud platform. Open Data Cube will provide a Python-based API for high performance querying and data access. Open Data Cube is very much collaborative to the government and private agencies that will be giving scientists and other users easy ability to perform exploratory data analysis, and will be helping to store a large amount of data, and will be getting in time series also. Coming to the data cube setup, I will be telling main steps. Install required applications for the setup of Datacube. Create a database using Postgres for testing and connect it to the database. Install Datacube core by cloning the GitHub repository. Verify by integration tests. And once it's passed, create a database with name Datacube. Add a product to the Datacube. Add the satellite images to the file system with the proper directories, and transform the metadata into the YAML, and add all these datasets into Datacube, and verify whether the datasets are working or not by running some analysis in Jupyter Notebook. Now, when the datasets are added, finally we'll be giving a command called cube-run, and then we could see that these are the products that are into the data cube. This data cube explorer is mainly to visualize and analyze satellite imagery stored in the data cube. This is a very interactive platform, and also it provides a graphical user interface to select, filter, and display satellite imagery based on the some criteria. Uh, this is all about the particular product is 2A underscore Centocore underscore granule, which is the Sentinel 2A product. This is the timeline from 1st Jan 2019 to 30th April 2020. This is the timeline of the data which I consist of. This is the area that I covered, 48,259 kilometers square. And we'll be having the data in the JSON or GeoJSON format. And coming to the product in a Datacube Explorer refers to a specific type of geospatial data that has been processed and organized in a consistent way for the analysis and visualization. In each product in a Datacube consists of a metadata that describes the data, such as the sensor used, the date and time of the observations, the spatial resolution, and the spectral bands available. The metadata is used to organize and search for the data within the cube. This is a database schema. The database schema consists of the dataset location, source, the dataset type, and the metadata type. These is all related to one another. And coming to NDVI, NDVI is a measure of the amount and health of the vegetation in a particular area. It is calculated by the formula NAR minus Z by NAR plus Z. The values ranges from -1 to +1. Higher values will be indicating healthier vegetation, and lower values will be indicating unhealthy vegetation. Now coming to NDMI, which is my analysis in this project. NDMI stands for Normalized Difference Moisture Index. This is the display of moisture content of the vegetation that uses SWIR and NAR bands. It is calculated by the formula NAR minus SWIR by NAR plus SWIR in according to Sentinel 2A, which is the band 8 minus band 11 by band 8 plus band 11. This NDMA values ranges from -1 to +1. The higher values will be indicating the higher water content. The high NDMA values could signal water logging, and decrease in the NDMI indicates the water stress. NDMI is mostly used to detect the crop irrigation. Now this is about my Flask application. In this picture, if you observe, I have integrated leaflet map, and by using this rectangle box, we could select our area of interest, and by clicking that, we will be getting our analysis. So if you observe, there are latitude and longitude, and this is the NDVI analysis which I previously explained. Mm, so I have kept two data sets. So this is the change. If you observe from 2022 to 2023, there is a slight amount of increase in mangroves in that particular area. The area that I have took is Nellore. Okay, coming back to the code uh, that I've done for my analysis. These are all the libraries that I have imported. Uh, some of are the digital Earth Africa tools that I have installed in my environment. And here I have given object named NDMI for my data cube. And I have loaded my data cube with the product signal to and some measurements. And I have printed my DS. The output is in the form of X-array dataset. X-array is the multi-dimensional dataset which is used to manage a large amount of data. So this is given just for sake of it measurements. Uh, so here coming to this is the RGB that I have given are band 8, band 4, and band 3. Those are NAR, green, and blue. So these are the two data sets. So the formula that I have applied, NAR minus HWR by NAR plus HWIR, and this is the final visualized plot which shows the variation in the water index. If you observe in 2023, there is a lot of NDMI, that means the moisture index is quite a lot increased, which results to the uh, growth of mangroves also. So finally, I'll wrap my project with the future scope. So the future scope is integrating machine learning algorithms into the data cube and developing a Flask application. So I wanted my front end to be a web interface with a map connected to the geospatial data that previously showed the map. And the backend is the Flask will be routing to handle user requests and serve the appropriate responses. The main development app we'll be doing is looking into the machine learning algorithms and integrating them into our application. Thank you.